Hello everyone, this is Shrikar. Today we are going to know about the temporal data structures and use cases. So today my topic is introduction to temporal data structures and use cases. So before going to learn about this topic, let us know some basic concept what is data structures and how it is used. So what are data structures? Data structures are specialized formats for organizing and storing data. It is used to store the different types of data in the different structure. So nowadays we are having multiple data from the world. We have like Instagram, Facebook, YouTube, or every data has to be stored in some point, some specific location on the internet or web clouding or cloudings. Further, we use data structures to store the particular data. So how the data was structured, how the data has to be stored in a different formats. So for that we require data structures. This helps to enable efficient data management and manipulation in computer programs. Like for storing of a data or some device, any programs, any files or anything data, they should the data structures helps to manage and manipulation the data. Understanding data structures is crucial for algorithm design and performance optimization. For storing the data in a particular format, we need to know more about the data structures and how the algorithm is work. So after the data structure, let us know more about it. Types of data structures. We have two types of data structures. They are primitive and non-primitive. Primitive data structures includes integers, float, and characteristics, while non-primitive data structures includes arrays, linked lists, and trees. In the primitive data structures, we have only a particular integers like only a single digit number, floats, and characteristics, only a particular single digit. While in the non-primitive, there will be like a number of a collection of integers or collection of floats or anything. These will be coming on non-primitive data structures. So each type of data structures has its own cases and performance characteristics. So here we have the data structure graph. Data structure is divided into two parts, primitive and non-primitive. In primitive, there are integers, float, char, char means character, pointers. And whereas in non-primitive, there are arrays, lists, files. In the list, we are divided further classified into two types, linear list and non-linear list. And these linear lists are classified into two parts, stacks and queues. Linear means there will be a sequence of data are stored in the, like there will be in a queue a particular order, whereas in the non-linear list there will be a different, there will be edges and nodes where the data has been stored. So next, let us know what is importance of data structures. Choosing the appropriate data structures can significantly affect the efficiency of an algorithm. If we use a proper structure algorithms in the data for the data storage, so there will be more efficiency and more less space and less time complexity will be used, so that we can decrease the power usages. Data structures provide the foundation for data organization, retrieval, and storage in software applications. Mastery of data structures is essential for an software developer or computer scientist. For the development of any software or any programs, we mainly focus on the data structures, how the data is being performed, how the algorithms are being run, how it is efficiently. So these will be basic key concepts of the basics of the data structures. So now let us go into our topic, introduction to temporal data structures. Here we the name temporal data structure means it is like a temporary data structure, or it is like time related data structures. So what is temporal data structure? Temporal data structures are specialized formats for managing data with time related attributes. Like it specifies like the data has been the data has been stored or it has been kept with a time relative. It is not a static, it is also a dynamic. Temporal data structure is also a dynamic data structures. Here, temporal manage temporal data structures helps us to manipulate and represent the time-based information efficiently. Now, for understanding the structures, so we require temporal data structures informations. So, how by the knowing the temporal data structures information, we can know how the applications involving time series data structures and history records, so that we know the algorithms and structures efficiently, and so that any changes can be done. Now, let us discuss what are temporal data structures. Temporal data structures are stored data structures. Temporal data structures store data points that are associated with specific time instance. They can represent in various forms such as absolute timestamps or relative intervals. Absolute timestamps means there will be a particular timings from this interval to this interval. So according to that, or else there will be a particular time, so that at the particular time the data will be stored or data will be recovered, taken from the real time to the storage data. So like let us take an example of the Airtel. So every day at 12 o'clock the data will be restored. So that this is a timestamps. So for every midnight 12 o'clock the data will be restored. If we have 1.5 GB data, so the data will be restored, and at the 12 o'clock we will get again 1.5 data. Now, while coming to relative interval, so there will be a particular timing, like from 12 o'clock to 3 p.m. What are the information has been there, where the data will be stored in that interval. Like when we are representing that, the data will be showing display lines from 12 to 3. These the information has been done. So this is called relative intervals. These structures often enable complex queries related to time, such as finding trends over periods. Suppose we have a huge complex data, we have in that number of datas. So from that, if we have a temporal data structure, we can pick the time interval. Suppose we want, if we have a day from 24 hours day, we want the information what has been done from 10 to 12 o'clock. The information has been stored in like in a temporal data structure. So from that we can take the data 10 to 12 o'clock data information, and we can represent that. It is a complex data structure in that we are dividing into a time interval, so that it helps to display the information. Now, let us know what are the importance of temporal data structure, how and how it is helpful in the day. In the present world, there are many uses with the help of temporal data. It is mainly used in finance, healthcare, IoT, and many multiple domains. So let us take example of an Google Maps. So we know that there will be a frequently change of the data in the data routes of the Google Maps. So for that they use the temporal data structures, and the data is been updated time to frequently. It is some time interval. Each time interval the data has been updated, so that there will be more efficiently and more accurately the user gets the best route. So suppose let us take an example. Suppose there is a static data, like there is a route from Mangalgiri to Amrita Vishwavidyapeetham, Amravati. So there have been some manholes and some construction has been constructing the roads. So there is a road blockage. So if there is a static data, so the Google Maps prefer the same road where the blockage has been there. So if there is a temporal data and the data has been updated real time dynamically, so the user will be able to know there is a blockage from on the road. So the user prefers to take another route. So it helps to make the user efficient. Helps now, the importance of temporal data, it supports the decision making by providing the insight how data changes over time. Like we said, example of Google Maps, it supports the decision making, how the user to take the preference of the road, which route is the best preference. So the temporal data helps to make the decisions. The ability to analyze temporal data can lead to more informed predictions and strategies. This helps to know more predictions and accurately Like if we are predicting something, by knowing the about, by knowing more information, we can easily, we can, it is not predicting, it is making an accuracy, it is can, it will be going to 100%. The common types of temporal data structure. We have three types of data structures. There are time series databases, event logs, and temporal databases. These are the three types of temporal data structures. Time series databases are designed specifically for storing and querying time series data. As we said, there is a particular time interval. So in this time interval, the data has been be stored. It is called the time series database. Event logs are structured record that capture events and their timestamps chronologically. Like in the while coming to the medical healthcare center, so there will be these event logs are helpful for storing the data with chronologically. Temporal databases extend traditional databases by adding time-related features for queries. This is helpful in the Snapchat. The main use the Snapchat uses the temporal databases, so which helps. So we can use by if you are a Snapchat user, we know there will be once view, and only we can view a data twice. We cannot multiply see the data. So it is comes under the temporal databases. Next, time series databases. Time series databases optimize data storage and retrieval for sequential time based data. Sequential time based data. As we discussed, the particular time interval from 12 o'clock to 3 o'clock, this data is a time sequential data. They often include features like downslamping and data retention policies for efficiency. Popular example includes timescale DB and each tailored for use specific use cases. While coming to event logs are critical for monitoring systems, capturing events with timestamps for analyzing. This is used in the software companies like Google, Microsoft, and other big companies. There we use servers as a event logs. So where the in the servers they store the data particular information. There will be a particular time for the backup data, so that it is helpful for you storing the software information. Suppose any um, suppose if any data corruption occurs in the company, so with the help of event logs, the data can be retrieved back, and it is very helpful. So next, coming to temporal data structures. Temporal databases maintain historical data alongside current data for comprehensive analysis. It stores history data and the current data. They will be compared with both. This is helpful for the artificial intelligence robots and anything machine learning. This helps to analyze and know the more information about the present real-time world. They support valid time and transaction time to track changes over different dimensions of times. This includes the Oracle Flashback technology and SQL Server temporal tablets. Let us discuss use cases of temporal data structures in financial analysis. In financial analysis, temporal data structures play a crucial role in managing and analyzing financial data that evolves over time. Financial markets are dynamic, and the ability to track historic data, perform time based queries, and analyze trends is essential for various applications like stock trading, risk management, portfolio, and market forecasting. There are some examples for the financial analysis. There are time series analyzing. This is used for the stock price, exchange rates, and commodities. And another one is portfolio management and asset allocation. Here, they allow visualization of historic price movements, adding investments strategies, and it's helpful in stock marketing. It checks previous data and compares the previous and compares the present data, so it predicts the future data. So this helps in financial analysis. Now coming to the use case in healthcare monitoring. In healthcare, it is very important so that in previously they are giving a hard copy for a receipt to store the data. Every time when we are going in the present, there we are using computers. So the computers, the information is being stored in a particular server. If sometimes if the person arrives again in a different time intervals, so when we are again, if we are trying to know about the information, should not be done to checking the previous data while with the hard copies. So instead of, while we are using the temporal database, here if we search the person information with the id or some different id or some information, we can able to retrieve the previous information, the history of the person, so that we can check what are the requirements of the done, what we previously check with the person, what are the, how can we done with the support. So they enable real-time monitoring and retrieval space analysis of patient outcomes. This data can support clinical decision making and improve patient care over time. The use of temporal data structures in IoT database management system. IoT devices generate continuous streaming of temporal data that needs efficient storage. Temporal data structures helps in managing sensor readings and event triggers over time. Analyzing this data can lead to improved automation and predictiveness maintenance. These IoT data management helps for the scientific and researchers. So these are the challenges uh, by these are the challenges in managing temporal database. Handling vast amount of temporal data can lead to perform bottlenecks in queries. Recently, we have had a issue with the Microsoft. The entire Microsoft has been completely shut down for a one to 3 to 5 hours. Because of that, most of the companies had a major loss, and the loss, even the flights has been cancelled due to the Microsoft shutdown. So by handling vast amount of temporal data, it can perform bottlenecks in queries, so that to ensure that data accuracy and consistency over time is critical. It's challenging. Developing efficient algorithms for temporal data analysis requires ongoing research. There will be a research regarding every day the management. So some of the companies are Timescale, Influx Data, Oracle Corporation, IBM Corporation, Crate.io. These are the companies. There are ongoing research regarding the temporal data. Now let us discuss future trends in temporal data structures. The increasing volume of time series data will drive innovations in storage solutions. Integration of machine learning with temporal data structures will enhance predictive analysis. Advances in distributed computing may lead to more scalable temporal data processing frameworks. Now, let us discuss best practice for implementation. Choosing the right temporal data structure based on a specific use case use case requirements. Regularly review and optimizing data retention policies to manage. Implementing robust data validation practice to ensure the integrity of temporal data. For the Google Maps, if we use static data structure, there won't be any helpful, so that for the particular application, there should be we should use a right temporal data structure, and we should be regularly reviewing. And if there is any regarding debugs or anything, we need to rectify it as quick as possible. So the conclusion of this temporal data structure are: temporal data structures play a crucial role in modern data management and analysis. Their applications span various industries, driving insight and informed decision making. These temporal data structures helps understanding and utilizing the structures essentially for leveraging time-based data efficiently. Thank you.